Hello, today's topic is ratios, but let's first take a look at two photos of our cats. This is Titan and this is Comet. You've probably already noticed that they're really not two different photos. The second one is simply an enlarged image of the first photo. Both the images are rectangular in shape, and if we pick a unit of length, such as millimeters or centimeters or inches, and then we measure out the width and height of the first image, surely those numbers will be different from the width and height measured out for the second image. And yet, there's a relationship between the height and width. Since I enlarged the photos correctly, I know the relationship, and let me give it to you by writing out a math equation. Width over height equals 3/2. So this is same as saying width divided by height equals 3 divided by 2. So for the first image, if you take its width and height and calculated width over height, it will be exactly equal to the fraction 3/2. Same thing for the second image. Width over height will exactly be same as 3/2. Another way of saying it is width equals 3/2 times height. So the width of each image is 1.5 times the height. In contrast, if we computed the quantity width minus height, then that width minus height for the first image will not be same as the width minus height computed for the second image. So this is the concept underlying the topic of ratios. Sometimes two quantities must be compared by considering the fraction of one quantity over another quantity. Same as saying one quantity divided by another quantity. Let's summarize this discussion and let's look at the formal definition of ratios. So we had this equation, width over height equals 3/2. This equation expresses a relationship between width and height. Now I want to give you some new language to say this exact same information. Here's the new language. The ratio of the width to height is 3:2. Here I've written 3:2, and we read this as 3:2. So what we were calling width over height, the fraction width over height, in my new words, in this new vocabulary, we are simply going to say the ratio of the width to height. And this equality symbol, as you already know, the same as writing is. And the fraction 3/2 in a new language of ratios is simply 3:2 written as 3:2. This sentence, the ratio of the width to height is 3:2, is conveying the same information as the equation width over height equals 3/2. So in this new language of ratios, I can tell you that for both the images of the cats that you saw, the ratio of the width to height is 3:2. Now in another situation, you may not have width and height, but you may have two quantities A and B, and you may want to talk about the ratio of A to B. And here's the formal definition. Suppose that A and B are two non-zero fractions. The ratio of A to B, denoted by A:B and read as A to B, is defined as the complex fraction A/B. So what this means is, this phrase, the ratio of A to B, simply means the fraction A/B. And this notation A:B simply is exactly same as the fraction A/B. And the reason I have written complex fraction here is because A and B could themselves be fractions. Then A/B would be one fraction, a fraction over another fraction, which you know is called a complex fraction. The language of ratios is useful and is in fact used in many contexts. So here are two easy examples. These days, many widescreen monitors feature a 16:9 screen. YouTube also uses a 16:9 ratio for its video player, and sometimes this ratio is called an aspect ratio. What this means is, for the image of the screen, the ratio of width to height is 16:9. If you prefer to see that in a math equation, it would be width over height equals 16/9. Now this piece of information was important for me to have, since I then prepared my slides in the 16:9 ratio. Here's another sentence using the language of ratios. The ratio of the number of girls to the number of boys is 7:3. From the definition of ratios, from our understanding of the word ratio as it's defined, that sentence simply translates to this equation. Number of girls equals 7/3. One quick comment. This sentence, the ratio of the number of girls to the number of boys is 7:3, is a little too long. So oftentimes you may find in word problems the shorthand version of it. The ratio of girls to boys is 7:3. Okay, two quick comments on this slide. This colon notation used in A to B is due to the philosopher and mathematician Leibniz. You will see his name when you take a calculus class in high school. Leibniz is one of the co-inventors of calculus. So he introduced this colon notation that we continue to use today. The concept of ratios existed before Leibniz, but this colon notation is what Leibniz introduced. Another comment is that in the definition of ratios, even though I've said A and B are two non-zero fractions, A and B could actually be any non-zero real numbers. They don't have to be restricted to fractions. We can still define ratios when A and B are non-zero real numbers. We'll explore that in another video. Okay, that's it for today. See you soon in another video. Until then, have fun with math. Thank you.